Have you ever been stuck on a math problem that looks crazy complicated, but then you find out there's this simple, elegant shortcut? Well, today we're going to unlock one of those awesome tricks for solving exponential equations. And the best part? You won't need any complex logarithms or anything. It's a total game changer. Let's dive right in.
So let's kick things off with a little puzzle. 2 to the power of x equals 16. Now, you might be able to solve this one just by looking at it, right? I mean, 2 times 2 is 4, times 2 is 8, times 2 is 16. So yeah, x is 4. But what happens when the numbers get a little trickier? That's where this shortcut becomes seriously useful.
The secret to cracking these problems really fast is what we call the same base rule. You can think of it as the secret password that just unlocks the answer that's kind of hidden inside the exponents. So the magic behind all this is something called the one-to-one property. It's a really simple but super powerful rule. It just says that if you have an equation where two powers with the exact same base are equal, well, then their exponents have to be equal too. It's just logic. This means once you get those bases to match up, you can basically ignore them and just focus on the exponents to solve the thing. And this property gives us a super simple 3-step game plan. Step 1, your job is to rewrite both sides of the equation so the bases are the same. Step 2, you just set the exponents equal to each other, creating a brand new, much easier equation. And finally, step 3, just solve that new equation for your variable. That's it. Let's see how it works in practice.
All right, enough with the theory, right? Let's see the strategy in action. We're going to walk through 3 examples, starting with a basic one and then working our way up to something a little more challenging.
Okay, first up, a problem that looks a lot like that puzzle we started with. 2 to the power of 3x equals 16. Our goal here is to figure out what x is.
So, step 1, we've got to get the same base. The left side is already a power of 2, so that's great. Half the work is done. Now, can we rewrite 16 as a power of 2? Oh, for sure. We already know that 16 is 2 to the 4th power. So now our equation is 2 to the 3x equals 2 to the 4. We are ready to go.
Now that the bases are identical, they're both 2, we can use our cool new rule. We just set the exponents equal. 3x equals 4. Now, it's just a little bit of simple algebra. Divide both sides by 3, and boom, we get our answer, x equals 4/3. Fantastic.
Okay, you ready? Let's step it up a notch. How about we solve 9 to the power of x equals 27? Now, 27 isn't just a simple power of 9, so this time we have to be a little more creative.
For step 1, we need to find a base that 9 and 27 have in common. What number do you think can build both of them? 3, right? 9 is just 3 squared, and 27 is 3 cubed. So after we rewrite it, we've got a power raised to another power on the left side. And remember, when that happens, you multiply the exponents. That gives us 3 to the power of 2x.
Perfect. The bases match. They're both 3. So let's set the exponents equal to each other. 2x equals 3. Just divide by 2, and we get our final answer, x equals 3/2. See? The same strategy works perfectly even when you have to tweak both sides of the equation.
All right, time for the advanced round. Let's tackle this one. 4 to the power of x plus 1 equals 1 over 8. Ooh, this one's got a fraction and a little more algebra up in the exponent. But don't worry, the same 3 steps are going to get us through it.
Okay, so what's our common base for 4 and 8? It's got to be 2. We can write 4 as 2 squared. Now for that fraction, 1/8, you have to remember that a negative exponent just means you flip the number. You take the reciprocal. So since 8 is 2 cubed, 1/8 is the exact same thing as 2 to the power of -3. This is a really key trick for handling fractions in these problems. And now we just set our exponents equal. So 2 times the quantity x plus 1 equals -3. We distribute that 2 across the parentheses to get 2x plus 2 equals -3. Then, subtract 2 from both sides, divide by 2, and we land on our final answer, x equals -5/2.
As you can see, this strategy is super effective. But there are a couple of really common mistakes that can trip people up. So let's just go over them right now so you can make sure to avoid them.
The first mistake, and I see this all the time, is with the power of a power rule. When you have a power that's raised to another power, you have to multiply the exponents. You don't add them. This is a huge distinction, so really burn that into your brain. Multiply, don't add.
The second common mix-up is confusing negative exponents with fractional exponents. They are not the same thing. 1/8 is 2 to the -3rd power. 2 to the 1/3 power is something totally different. That's asking for the cube root of 2. So just be really careful to keep those two rules separate in your mind.
So there you have it. You've now got this really powerful new tool in your algebra toolkit. But you might be thinking, okay, that's cool, but when am I ever going to use this in real life? Well, let's take a quick look.
The truth is, this isn't just some abstract math exercise. The same base rule is actually the foundation for solving tons of real-world problems that involve exponential growth and decay. I'm talking about calculating compound interest, modeling how bacteria grows, or figuring out the half-life of a radioactive element. The logic starts right here.
So, you've now mastered this fantastic shortcut for when you can get the bases to match up. But that leads to a really interesting final question. What happens when you just can't? How in the world would you solve for x in an equation like 3 to the power of x equals 10? There's no simple common base there. And that, well, that's a challenge for another time.